particle is thrown vertically upwards and returns to its point of projection after 10 seconds. Assuming the air resistance is negligible, find the initial speed the particle is thrown and the maximum height reached. So if we draw a little diagram, so there's the ground, we throw the particle up, gravity will reach a maximum height and then it will fall back to ground. Okay, we want to find the initial velocity that it's thrown up. We know the time it takes for the flight is 10 seconds. We know if we go up and down that the displacement will be 0, and we know that gravity acts downwards at minus 9.8 meters per second squared. So S will be equal to UT plus a half AT squared. Where it touches the ground again, the displacement will be equal to 0. So if we put 0 equal to 10U plus a half times gravity, which is minus 9.8 times 10 squared, we get 10U minus 490. 10 squared is 100. Half of 9.8 is 4.9. 100 times that gives you 490. It's minus. Therefore, 490 is equal to 10U, and therefore U is 49 meters per second. That's the initial velocity. Right, having found that, we can now find the maximum height reached. At the maximum height, V is equal to 0. So at the greatest height, V is equal to 0. So using V squared is equal to U squared plus 2AS, where we got to find the value of S. We've got 0 because at the maximum height, the final velocity is 0. The initial velocity is 49, so it's 49 squared, plus 2 times the gravity, which is minus 9.8 times S. So that's going to give 0 is equal to 2,401 minus 19.6 seconds, 2 times minus 9.8. So 19.86 S will be equal to 2,401, and therefore S will be equal to 122.5 meters. So the greatest height reached will be 122.5 meters. Okay, so there's been a video of a particle being thrown vertically upwards, finding the initial velocity and finding the maximum height reached. I hope you've understood, and I thank you very much for watching.